Hello guys, this is Paul McWhorter with TopTechBoy.com, and we're here today with episode number 59 in our incredible new tutorial series where you're teaching your Raspberry Pi who's boss. What I will need you to do is pour yourself a nice tall glass of ice cold coffee. That would be straight up black coffee poured over ice, no sugar, no sweeteners, none needed. And as you're pouring your coffee, as always, I want to give a shout out to our friends over at Sunfounder. Sunfounder is actually sponsoring this most excellent series of video tutorials. And in this class, we are using the Sunfounder Raphael kit for Raspberry Pi. Most of you guys probably already have your kit, but if you don't, look down in the description. There is a link over to Amazon. You can hop on over there and pick your gear up. And believe me, your life and my life are going to be a whole lot easier if we are working on identical hardware. But enough of this shameless self-promotion. Let's jump in and talk about what I'm going to teach you today. What I'm going to do is I'm going to give you my solution to the homework assignment that I gave you in lesson number 58. So I must ask, how many of you guys were successful? If you were successful, leave a comment down below. I am legend. Double chest bump. And if you were not successful, leave a comment down below. I folded up like a cheap Walmart lawn chair. But hopefully a few of you guys got it, and the rest of you, never fear, I will show you my solution today. So let's jump over here and let's take a look at what the assignment was. Where we ended up with last week is, remember, we have the Raspberry Pi camera mounted on this pan tilt servo hat that is on the Raspberry Pi. And what we had done is we had trained in OpenCV, we'd trained the Pi to recognize an object of interest, and then we had a simple control system where as we moved the object of interest around, the pan tilt servo hat would respond to always point to keep the center of the object of interest in the center of the frame. Did it work? Yes, it worked. But what did we not like about it? We didn't like that it was kind of slow. And what it would always do is it would always make corrections 1 degree at a time. And so if we were 20 degrees off between the center of the frame and the center of the object of interest, how would we take that error out? By taking 20 little bitty steps. And so that was kind of slow. And so taking small steps is not really a very good way to do it. Well, you might say take big steps, but if you take big steps, you might jump over the object of interest and miss it, and then your control system would go into oscillations. So big steps are not the answer. Small steps are not the answer. What is the answer? To take smart steps. And that's what I'm going to show you how to do today. I think the best thing for us to do is to start off where we left off last week. And so let's grab that code from how we did it in the last lesson. And so I need you to come over to www.toptechboy.com, and then using this little search icon here, you could search on something. You could search on something like Raspberry Pi Lesson 58 Control System, and then you can come down here and you can click these two little pages, and then you will copy the code. And then what you can do is you can come over to your Raspberry Pi and you can come to Thonny, and then you can paste that code in. Always what I like to do is I like to start to make sure that my old code still runs, just so I don't start doing a lot of development and see that something is wrong. So let's come in and run this thing. I'll put my object of interest down here where hopefully it can find it. We will come over here and we will run it. It should work. I really think that it should work. We've got a bunch of windows popping up here, and so let's see if I can get these windows kind of in a reasonable location. And what I need to do is I need to try to dial in on that yellow cap. So I'm going to open up the yellow a little bit. I'm going to tighten up on the bottom end, and then I'm going to tighten up these hue and saturation values a little bit. And now I'm in the train mode. I'm ready to what? I am ready to turn on the track mode. So I will come down here and I'm going to switch from train over to track, and then boom, what happens? It brings that object of interest into the center of the frame. If I move it to the left, the camera tracks to the left. If I move it to the right, the camera tracks to the right. If I move up, it tracks up. If I move down, it tracks down. So it is working. So why don't we like this very much? Well, what happens if I move it kind of fast? I move out of the frame and then it loses the object of interest. And so we want something that works a little bit better than that. So what do? We always start by drawing things. So let's come over to the sketch pad and let's kind of talk our way through it. But let me just show you one more thing. Always when we were adjusting the tilt angle or the pan angle, we were always adjusting it by 1 degree. Even if I had a really large error, we would either add 1 degree or we would subtract 1 degree, but we always adjusted things by 1 degree. What do we want to do? We want to do things a little bit smarter than that. So let's come over here and we will get out our sketch pad and we will draw this thing up again. Okay, so what do we always start with? We always start with our frame. So I will draw our frame here. And then from the earlier week's lessons, what do you always know? You know that the width of the frame we call DISP, uppercase W. What is the height of the frame? We call that DISP, uppercase H. And then what do we really care about? We care about the center of the frame. Where is the center of the frame? Well, it's halfway over. So the x-coordinate would be display W like that, divided by 2. And then where is the y-coordinate? Well, it's halfway down, which would be display height divided by 2, like that. Now we have the center of the frame. Well, what do we also have? We also have an object of interest. And so I will draw our object of interest over here like this. Okay, and that object of interest also has a center point. Well, how do we get that? Well, we know from last week's lesson that that bounding box that we calculate, it gives us the xy coordinate of the upper left corner of the bounding box. It also gives us the width of the bounding box and the height of the bounding box. So what is the coordinate of the center? Well, it's the x of the upper left corner plus half the width. So it's x plus w over 2 is the x coordinate. And then what is the y coordinate? It is y plus h over 2, like that. So now I have the coordinates of the center of the box and I have the coordinates of the center of the frame. Are they in the same position? No, they are not in the same position. So I have a what? I have an error. And we'll calculate the error this week the same way as we did last week because the error is the error. So the error, and remember this is the pan error, it is equal to what? It's equal to this coordinate, x coordinate, minus that x coordinate. And so it is equal to x plus w over 2 minus display w over 2. That is the error. Okay, now how did we handle the error before? Well, the way that we handled the error before was if the error was positive, as it is here, if the error was positive, what? I need to rotate. If the error is positive, I need to rotate the camera clockwise, and therefore I do that by subtracting 1 degree. Okay, and if the error was negative, I would add 1 degree. Okay, subtract 1 degree or add 1 degree. If the error is huge, I would change by 1 degree. If the error was tiny, I would change by what? By 1 degree. Now, what would that mean? That means if I have a huge error between here and here, how would I drive that error out? By taking a whole bunch of little bitty steps like this, little 1 degree steps until I drove it out. But what happens if this thing is moving fast? It's going to move off the screen and I'm going to miss it. So I need to make what? I need to make smarter steps. So what if we did this? Instead of always correcting by 1 degree, what if we corrected by an amount proportional to the error? What if we tried to take half the error out? So in my first jump, I would come to here. And now what do? I take half the error out again. In my second jump, I come to here. In my third jump, I come to here. And then by the fourth jump, I am at my target. I am taking smart steps. Big steps when I have big error, small steps when I have small error. And kind of like a place that you can start is trying to take out the half the error in each step. Well, then how would we do that? Okay, how would we do that? What I would say is, remember, we're working in pan. I would say that pan angle is going to be equal to pan angle. Okay, pan angle is going to be equal to pan angle. And then I am going to subtract some fraction of the error. Now, we said that we wanted to take out half the error, so you might think divide by 2, but you got to remember error is in pixels, and we're talking about angle here. And we said that there were about 35 pixels in a degree. And so if we want to take out half the error, we would divide by 2 times 35. We would divide by about 70. And then that would take out half the error because we got to normalize the difference between pixels and degrees. But I want to be a little bit on the safe side, and so I want to take out 100. Now what we have to see here is, in this case, from here to here, the error is positive. When the error is positive, I want to what? I want to move clockwise. How do I move clockwise? I have to apply a negative, and that is why we are subtracting the error. Now, what happens if our error is negative? If our error over here, if we are over here, our error is negative. For a case of a negative error, what do I want to do? I want to go counterclockwise. So I would what? I would still want to subtract the error which is negative, which would give me a positive value, which would go counterclockwise. And so the quirky little thing is we no longer have to do a different equation for positive error and negative error. In both cases, we just simply subtract the error divided by 100, and everything is going to work out in the wash. Pause and think about that and make sure that you understand it. So what I'm going to have is I'm going to have very simply here one equation. Pan angle is equal to pan angle minus the error, and right, that's the pan error divided by 100. Now we're going to start there, and if it works, then we're going to come in and try to be a little more aggressive, and we're going to see if maybe instead of dividing by 100, we could divide by 75 or divide by 50 and getting this thing to operate a little bit more high performance. But I don't want to lose control of my control system, and so I'm going to start conservatively, and then we'll start dialing in that parameter, if that makes sense. Now let's think of the other case. Let's think of the case down here. So I'm going to draw again. I'm going to draw for the tilt case. Okay, I'm going to draw for the tilt case. So here we have a tilt error, right? We've got a tilt error of this amount. And so what is this point? This point is going to be the y value, which is y plus h divided by 2. Okay, and then what? We are going to subtract the display height divided by 2. And that is this error here. All right, now what do we do with that error? In this case, the error is positive. If the error is positive like that, I want to what? I want to point down. And to point down, I need to add. Okay, so in the previous case, we were subtracting the error. Here, for tilt, I want to add the error. But now let's come up here and let's think about the case of negative tilt error. Okay, this is the case of negative tilt error. If the error is negative in tilt, what do I want to do? I want to point up. Okay, I want to point up. And how do I point up? I point up by subtracting, which would be work if we add the negative error. And so again, one equation is going to work here. And what that equation is going to be, the tilt angle is equal to the tilt angle plus the error divided by 100. So I don't have to look at the pan angle and say, is it positive, negative? One equation will work for both of them. And similarly, on the tilt, I don't have to go and look at the positive and negative error case. One equation will work. So what do I have? I have two equations, and those should work for pan and tilt. How cool is that? Now, if you don't understand that, think about what I'm saying, and it should make sense if you go back and kind of draw it out and think. Okay, what do we need to do now? We need to come back over to our code view. We need to come back over to our code view. And again, we're starting where we left off in last week's lesson. But what I want to do is I want to come in here, and what two things do we know? I'm not going to try to edit this. And so the error for pan is still the same as it was before, but then we're just going to redo all the rest of this stuff. And I'm going to need my keyboard here. We're going to redo all the rest of this stuff. I could try to keep some of the code, but I think it's easier if I just type it in again. And then we're going to come down here, and we are, okay, this is error and this is tilt error. And so those two things are still good. And then we'll come down and we'll get rid of all that. So the only two lines of code that I'm keeping is calculating error, the pan error, that's still the same. Calculating the tilt error, that's still the same. But now what do we do with the pan error or the tilt error? Well, now I have the error, I can calculate the what? The pan angle is going to be equal to the pan angle, and for pan we what? We subtract the error. What do we want to divide by? Well, right, we said if we divided by 70, that would take out half the error, but we want to be conservative, so I'm going to divide by 100, and then we'll come and see if we can push that in a minute. Now, we do want to make sure that we're not overdriving it to the left or overdriving it to the right, so we do want to put those limits on it to make sure that we don't damage our servos. So I'm going to say if pan angle is greater than 90, then I want to pin it at 90. So I'll say pan angle equals 90. I don't want it to escape on the other side, so I'll say if pan angle is less than minus 90, same thing, I will set and pin the pan angle to pan angle. I'll pin it to minus 90, like that. Now, I should be ready to, I've got a good pan angle, I should be ready to set it. So I'm going to say pan dot set angle, and I'm going to set it to what? Pan angle, like that. All right, now let's do the tilt. I've got the tilt error. Now, what do I need to do? I need to adjust the tilt angle. Tilt angle is going to be equal to tilt angle, and then plus, this time plus tilt error divided by 100. Now I've got my tilt angle. Now I've got to make sure I don't overdrive an angle. And so I'm going to say I'm really concerned about the pointing down. That's the positive angle. So I'm going to say if tilt angle is greater than 40 degrees, because I don't want to crash that thing into the base, I'm going to set tilt angle equal to 40. And then on the tilting up side of things, I'm going to say if tilt angle is less than minus 90, then I'll say tilt angle is equal to minus 90, like that. So let me take a look at that. Now I've got a good tilt angle. What should I do now? I should apply that tilt angle. So I will say tilt dot set angle, and what am I going to set it to? Tilt angle, like that. So what is the main difference? The main difference is the signs are taken care of because of the sign of error. All right, so I don't have to check for positive error or negative error. It all comes out in the wash. And then what is the other thing? I'm not always changing by 1 degree. I'm changing by an amount that is proportional to the error. A large error, I do a large change. A small error, I do a small change. My correction is proportional to the error. How many mistakes did I make in here? Let's see if this thing will run. I will need you to hold your breath. Oh, boom. Okay, at least it's running. That doesn't mean there's not going to be a crash in here somewhere else, but let's see if we can kind of get a few of these things where you can see them. I need to get some sort of target in here that I can train on. I need to get my track bars over here. And now what I'm going to do is I'm going to open up on that yellow. That is looking pretty good. I'm going to tighten up a little bit on this side. I'm going to tighten up on these values, and that looks pretty darn good. What am I ready to do? I am ready to turn the track on. So here we go. You can see that I've got this little slider bore. We are turning the track on. Hopefully, there it goes. Okay, good news is it didn't just glitch out completely out of control. I like to start kind of with simple moves just to make sure that I don't have something crazy happen. So moving to the left, looking good. Moving to the right, looking good. Now, do you see if I move quickly how it makes bigger steps? It is making bigger steps. Look at that. Now, let's look going up. It is tilting, coming down. It is tilting, moving. Now, let's just see if I can come back over here and just be moving it, you see, and it's what? It is keeping that object of interest in the center. And do you guys see, watch the little inset of the camera. Do you see how fast that camera is moving now? Because it is moving in proportion to the error, and large error means that it's making large steps. Okay, I like that. But I want to push it a little bit more. That's really more like taking 1/3 of the error out per step. Let's see if we could take half the error out per step, and that would be more like divide by 70 and divide by 70. And let's see if that works. We're going to come up, we're going to run it. Got to give it something to see here. There you go. Now let's see if we can train it again. Okay, we'll open up that yellow. We'll shut that down a little bit. Shut that down a little bit. Turn the tracker on. Okay. So you see, it looks like it's kind of glitching a little bit more, but then let's see how fast this is. Oh, wow. Do you see how fast that is? Okay, it is really keeping up. It is really keeping up. Do you see how fast I'm moving that? Okay, now let's see if it comes down. Let's see if it comes down. Okay, it looks like it's moving really quickly, but then it looks like it's a little bit more unstable. It's a little bit more unstable that it just doesn't come in. It's got a little bit of that end oscillation. And so I'm going to show you what I like is I like dividing by 70 because it moves so fast, but then as it comes in for a landing, it gets that glitchy business going. So let's go back and kind of do what we learned last time and make sure that we're not trying to remove an error that is less than 1 degree. And so how could we do that? How could we do that? Well, I'm only going to set the tilt angle. I'm only going to set that tilt angle, and I'm putting it like that so I can put it in an if statement. I'm only going to set that tilt angle if the absolute value of the tilt error, if the absolute value of the tilt error is greater than 35 degrees. So I'm only going to try to move the servo. I'm only going to try to adjust if the error is greater than 35 pixels, is greater than a degree. Because if it's less than a degree, I'm just going to sit and go back and forth. So I'm only going to change it. And so if it's greater than 35, it'll try to move it. If it's less than negative 35, it'll try to move it. Otherwise, it's going to stay put. And hopefully that will take out some of that nonsense that we're seeing. I'm going to do the same thing up here. In this case, I'm going to say if pan error is just error. I really wish I'd called that pan error from the start. But if error, and again, it is going to be if the absolute value of the error is greater than 35, then what will I do? Then I will try to set the pan. Okay, so what I hope here is I hope it'll move fast, but then it'll come to a nice, quick, stable endpoint. So let's run it. What? Doesn't like line 108. What did I do? You got to put the colon there. Okay, rookie mistake. Let's go. Okay, it looks like it has come to life. Let's bring this up where you can see these things. Okay, let's see if we can dial in on that yellow a little bit better. Let's see if we can dial that in. I'll open that yellow up a little bit. I'll tighten up on that side. I'll tighten up here. I'll tighten up here. I'd like to get that a little bit. I don't like how that's jumping around a little bit. Okay, give me just a second. I want to get that a little more stable. Okay, I think that's good. Now let's turn our servo on. Okay, look at that. Did you see how quickly that thing, do you see how quickly that stabilized? Now let's see, we're going to, whoa. Okay, that was not good. Let's go up. Okay, let's come down. Let's go across. Man, I lost control of it there for a second. I'm not sure what happened. Let's see if we can see this side. Okay, we'll go up. We'll come down. Do you guys see how fast this thing is moving? You guys look at that inset camera. Do you see how fast it's going? But then what does it do? Boom, it comes into a very stable landing. And so using this, what we see now is I've got something that moves fast, but then stabilizes quickly. Moves fast, but stabilizes quickly. Do you think we should try to push it just a little bit? Let's come in. Let's see if instead of dividing by 70, what happens if we divide it by 50? This is taking out a bigger chunk of the error in each step. I don't know if this will work or not. It could just, you get to the point that you're just going to get completely unstable when you're playing around with things like this. But let's see if the 50 would work. So I need to open that up. I need to squeeze that in a little bit. Come in here. Come in here. And now we are going to turn the track on. And yeah, that didn't go well. That didn't go well. Did I introduce like an error in there or something? Let's see. Oh yeah, divided by 5. That would not be good. That would not be good. Let's try it again. Okay. I was thinking that 50 might not work, but it shouldn't have been that bad. So we'll open it up. We'll tighten it up. We'll tighten that. We'll tighten that. And now let's turn the tracker on. Okay. So let's see if I move it. No, you see it's too unstable. So the 50 just isn't gonna. I can't even get over here to stop that thing. Stop, you aggravating thing. Okay. So yeah, I divided by 50 and then let's go back to 75. And then go to 75. So you see, that's what I say. Setting these control parameters, it's partly science and it's partly art. So you've got to kind of learn how to dial these things in. And so let's see if we can get stable operation here at about 70. And so I will dial that in. I'll tighten it up a little bit. I'll tighten this. I'll tighten this, and now I will turn the servos on. Okay, boom, that came right in. Move it over here. You see, I'm moving it fast. See how I'm moving it all around? And then I put it down. Okay. And I think that's stabilizing really fast. I'm happy with that. Okay, guys, I am going to call that good. I am going to call that good. Now, do you understand what we've done here? We didn't take small steps. We didn't take big steps. We took what? We took smart steps. So now what we have is we have an excellent control algorithm. We have an excellent control algorithm. It just really kind of went crazy there. Let me kill the program. You guys don't see what's going on here, but I goofed it up. Okay, we're not taking large steps. We're not taking small steps. We're taking smart steps. Now, what are we tracking? We're tracking a yellow pill bottle, vitamin bottle cap. All right, that's our object of interest. But we have a control system that will track an object of interest. What is our next step? It's to start going beyond tracking on color and start tracking on more interesting objects of interest, like maybe a face. Can we look at a frame and can we find a face? Can we look at a frame and find an eye? Can we look at a frame and find the tip of a pinky finger? Okay, so that is what we're going to be doing now. We're going to be moving into a little bit deeper into artificial intelligence and starting to find more interesting objects of interest. Guys, I hope you're having as much fun taking these lessons as I am making them. If you enjoyed the lesson, give us a thumbs up. It also really helps us with the old YouTube juice if you'll leave a comment down below. If you haven't subscribed to the channel already, make sure you do. When you do, ring that bell so you'll get notifications when our future classes drop. And then, as always, make sure that you share this video with other people, because the world needs more people doing engineering and fewer people sitting around watching silly cat videos. Paul McWhorter with TopTechBoy.com. I will talk to you guys later.